Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Today I want to take you through the part 2 for the tips on how to ace mathematics paper 1 exam for grade 12. Right, initially we went through part 1 where we focused on the first part is algebra, sequence and series, functions and graphs, financial mathematics, and also, I think this is what we've done already. We went through all the topics from algebra up until financial mathematics. If you have not watched my first video, kindly follow the link that I've shared below of the part 1 for how to actually tips on how to ace mathematics paper 1 exam paper. Right. Again, don't forget to like, subscribe, and hit the bell notification for future video updates. Right, ladies and gentlemen, without wasting time, let's now go through the last 3 topics, that is differential calculus, probability, and the fundamental counting principle. Remember, I have indicated from the first video that topics like algebra, topics such as functions and graphs, sequence and series, financial maths, these are the giant topics where you need to make sure that you allocate. You get a lot of marks actually. They're just easy. And also the other one is the issue of differential calculus. Not forgetting that probability and the fundamental counting principle. This one do not have a lot of marks, but you need to also be able to familiarize yourself with this. You need to make sure that you understand all of the topics of probability and fundamental counting principle. Right, without wasting time, let's now talk about differential calculus. Right, guys, in terms of differential calculus, you need to understand that usually in the exam, differential calculus comes in 3 equations. So this is one of the topic that allocate a lot of marks. So you need to understand how to actually solve problems that are relating to differential calculus. Number 1, under differential calculus, we have what you call the first principles. This is the first question actually in differential calculus. Ladies and gentlemen, the first principle, as you know, it states that the f prime x is equal to the limit when h approaches 0 of f of x plus h minus f of x all over h. You need to be able to familiarize yourself with the first principle formula. And guys, remember, one other thing that you need to understand, that the reason of learning differential calculus is we want to actually understand on how to actually calculate the gradient. The gradient of actually a line, the gradient of a line at a point. Or actually, we're going to talk, like the reason of learning calculus is actually to know more about gradient. Actual gradient of a line at a point. Or we can just say we learn differential calculus to know more about how to determine the gradient at the point. That's why this formula f prime x from first principle, this comes from what you call, like we estimated by using limits from the gradient of a secant to actually get the gradient of a function at a point. So you need to be able to know that when we are dealing with derivative or f prime x or dy over dx, this is the same as a gradient function, particularly gradient at a point. Right, then now, this is the longest method of finding a derivative. So f prime x, as I said, is equal to the limit when h approaches 0 of f of x plus h minus f of x all over h. So this is what you need to know. This is the formula that you need to know on how to find the derivative of a function from first principle. This usually is the first question of differential calculus. Now, when you are dealing with this, you must also be able to know the notations of finding a derivative, notations of finding. For example, sometimes you can say f prime x. In other book, we can say dy over dx, which means we're differentiating y with respect to x, or we can use d operator x, or we can even use y prime. So this is one and the same thing, which represents the derivative of a function, or the derivative, yes, the derivative of a function with respect to x. This one is the derivative with respect to x. But it's not about looking at the derivative with respect to x. It also depends on the question. For example, we can look at dy over dt. So which means we're differentiating y with respect to t. So this is what you need to be able to understand when you are dealing with first principle. And guys, first principle, it's one of the easiest. It's one of the easiest question, particularly in differential calculus. And this first principle, as I said, that it is the longest method of finding a derivative. But we still have other method of finding a derivative, which we call this the rules of differentiation. Rules of differentiation. So which means that in most of the equations, if they say use first principle to find the derivative, it means they want you to use that formula of the limit when h approaches 0 of f of x plus h minus f of x all over h. But still, we still have other rules or other method that we can use in finding a derivative. Then I'll talk about the rules. Rule number one says, if we have y equals to x to the power of n, okay? And now we want to determine what is dy over dx. So we want to differentiate y with respect to x. So since we are differentiating y with respect to x, it means the exponent that the power should come down. So the derivative will be n x raised to the power of n minus 1. So this is the first law, the first rule that you need to know when you are dealing with differentiation. Then secondly, we have what is called the second rule, which says if y equals to, this is the second one, it says if y equals to kx, where k is constant, then to determine dy over dx. So it means we are differentiating y with respect to x, then the answer becomes k. The answer becomes k. Why are we saying the answer is k? We can still use the first rule. Because this is the rule that we can use to prove this. Why? Because now we want to differentiate our function with respect to y. So we are determining the derivative of a function. The derivative of our function y with respect to x. So it means now the x is the parameter of interest, or the variable of interest. So I can say if you have y equals to kx, and we are told to determine dy over dx. So we're differentiating y looking at x. Obvious, what is the exponent on x? It's 1. So which means we're going to use this rule to say we bring down the n, we reduce the n by 1. So this will be k multiplied by 1 times x into 1 minus 1. So which becomes k times 1 is k, and x to the power of 0. We know that any number raised to the power of 0 is 1. So this will be k multiplied by 1. That's why we said the derivative of kx is k. So the derivative of kx is k. So I was just proving to you that why are we saying the derivative of kx is k. And another one, it is the issue of, I think it's rule number 3, which says if you have y equals to k, where k is just a constant. If we have y equals to k, where k is a constant. So how do you determine, let's say we want to determine what is the dy over dx. Dy over dx here will be 0. Why? We want to differentiate our function with respect to x. And since there is no x here, it means this is now a constant. And according to the principles of differentiation, it says the derivative of a constant is 0. Derivative of a constant is always 0. So the derivative of a constant is 0. Let's just do one example. I think this is what, like, a learner who want to enjoy differential calculus must be able to know how to make a derivative. Remember, we use first principle only when they say from first principle, but usually to make a derivative, we use the rules of differentiation. Rules of differentiation. So first principle can also give us the same answer, but that one is a longer method of finding a derivative. So for example, let's say we have y equals to x to the power of 3. So let's say we want to determine what is dy over dx. So you see, we're differentiating y with respect to x. And since x is there, it means you're going to use rule number 1. What is the exponent there? 3. 3 should come down. So this will be 3x, 3 minus 1. So it means the answer becomes 3x squared. So which means the derivative of x cubic, it's 3x squared. So these are the things that one must be able to know. Remember, you need to know the basics in order to enjoy differential calculus. Differential calculus is one of the easiest. Now you need to make sure that you know how to differentiate. For example, if I say, if you have y equals to, let's say, x to the power 5 plus 4x squared minus 9x plus pi. Let's just say pi. And we are asked to do what? To find the dy over dx. We need to differentiate y with respect to x. So we want to get dy over dx. Now, how are we going to get dy over dx? So we're going to say, okay, fine. We're going to use those rules to say, okay, now we have the dy over dx, which means we're differentiating with respect to x. So let's check. Do we have x on the first term? Yes, the x is there. So what is the n? What is the exponent? It's 5. So it means 5 will come down and we reduce the 5 by 1. This will give us 4. Plus, with respect to x is there. What is the exponent? Is 2. We bring down the 2. 4 multiplied by 2. X into 2 minus 1. Plus kx. This kx, 9x. What's the derivative of kx? It's k. So which means what is the derivative of 9x? It's 9. But now, look at this. You want to find the derivative with respect to x, not with respect to pi. But since there's no x here, it means this is called a constant. This is a constant. And what is the derivative of constant? The derivative of constant is 0. So which means the final answer becomes 5x to the power 4 plus 8x plus 9. So that is the answer. So it means when you are dealing with differential calculus, you need to be able to know how to differentiate. You must be able to know how to differentiate. Then another thing that is very important, guys, is the issue of considering when you are making a derivative, when you have an expression that is in the form of a fraction, or the expression that is in a fraction form. For example, let's say you have this, let's say you have y equals to 4 over x to the power of 3. And from the exam, you are asked to determine dy over dx. Then according to the intuition, if you do this, if you say, because I'm differentiating y with respect to x and my x is here, and what is the exponent is 3, then you say this is the answer, it's 4 divided by 3x to the power of 3 minus 1, which is 2. Then this is wrong. We don't do this. Why? Let me explain to you. When we are making a derivative with respect to a parameter, the parameter that we are making derivative with respect to, it's not supposed to be at the denominator. Unless when you go to university, we can still differentiate this by looking at the way it is without having to simplify it, which you'll learn more about that. We have what you call the quotient rule and the product rule and the other. So which means that all the time when you are making a derivative of a function, you need to always consider that the denominator must not be, when you are differentiating, whatever you're differentiating with respect to, it's not supposed to be at the denominator. You need to move it. It's not supposed to be at there. It means you must take it to the numerator. And how do you do this? Let me remind you. Remember, we have what you call the exponents, where we said when we have 1 over x to the power of n, this is the same as x to the power negative n. So what does this mean? It means you are just playing around with the exponents. If the exponent here is n, and this n is positive, when you take it up, it changes the sign, it becomes negative. You bring it down, it changes. So it means here, the exact method should be y equals to, we have to bring, we take this x to the power of 3 upwards. It means the exponent will change. Instead of being positive, it will be negative. So it means the answer will be 4x to the power minus 3. You see what I've done? So it means I no longer want my expression. Like I want the variable x to be at the numerator so that I can be able to differentiate. Yes, if it's like this, then it means it's simplified. That's what we can start to do now, the dy over dx. So we're differentiating y with respect to x. And what is the n on x? The n is minus 3. So we bring down the n. This will be 4 multiplied by minus 3x to the exponent minus 3 minus 1. So what is the answer? The answer is minus 12x to the power minus 4. So it's either we leave the answer like this or we change it to have positive exponent. And what do this? You just play around with the exponent. If it's negative, when you bring it down to positive, so you're going to have minus 12 here. Then we bring this down. This will be x to the power of 4. So this is the answer. So it means you need to know all the time that you mustn't differentiate a function with respect to parameter that is at the denominator. It's very important. Any parameter that is at the denominator, if you want to differentiate with respect to, you need to move it there. So it's very, 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 very important when you are dealing with differential calculus. Then another thing that is very important if you want to enjoy differential calculus, it is the issue of understanding SADS, the SADS expression. For example, if we have, you need to be able to know how to deal with SADS. SADS are very important when you are dealing with differential calculus. Number one, we know that the square root of any number, it is that number to the exponent of half. So the square root of a, it's a to the exponent of half. This is very important. And another thing is the issue of the nth root. The nth root of a. The nth root of a is the same as a raised to the power 1 over n. So it means you're controlled by this n. So it means where there's a square root, actually there's a 2 there. So which means now, for example, if you say, what is the cubic root? What is the fifth root of a? It means this becomes a to the exponent 1 over 5. A to the exponent 1 over 5. That is the fifth root of a. So it's very important for you to be able to know this. Square root of a is a raised to the power of half. Square root, the nth root of a is a to the exponent of 1 over n. So these are very important when we are dealing with differential calculus. And one other thing is the issue of knowing exponent. Again, we know that in terms of exponents, when the base are the same for multiplication, what do? We take one base and we add. But when the base are the same for division, when the base are the same for division, we take one base and we subtract just 2 minus 1. So it's very important to know this. And again, when we have, let's say, a to the exponent of x, everything to the exponent of y, then these exponents can multiply each other. So this will become a to the exponent xy. So these are the things that you need to be able to understand when you are dealing with differential calculus. Don't forget, guys, I said differential calculus comes in how many questions? 3 questions usually. So which means the first question of differential calculus, they want to see whether you are able to use first principle and the rules of differentiation. Remember, whether you're using first principle or whether you're using the rules of differentiation, the answers should be the same. Right, I'll create a video where I'm just going to solve differential calculus questions. Here, I just want to remind you that if you want to get a lot of marks under differential calculus, you need to be able to know what I'm actually telling you. SADS, the root of a is a to the power 1 over n, and the nth root of a is a raised to the power 1 over n. These things are very important when you are solving differential calculus. First principles and the rules of differentiation. For example, look at this. Sometimes when in the exam, if they say to you, determine f prime x from first principle, already you can get the answer, you can confirm the answer before having to use first principle to check what is the answer that you're supposed to get. And to do that means you can use rules of differentiation. For example, let's say you are given this, they say determine f prime x, which is the derivative from first principle, if f of x, let's say f of x is x squared plus 3x. Yes, f of x equals to x squared plus 3x. Obvious, since they're saying we need to use first principle, obvious means they need us to use a long method of finding a derivative. However, there is a short method of confirming the answer, which are the rules of differentiation. So what we can do, we can say on the side, this side, then we say, okay, what is the answer that we're supposed to get? We're going to use the rules of differentiation to confirm the answer. We differentiate f with respect to x. What is the power on x is 2. We bring down the 2, we reduce the 2 by 1. So this will be 2x, 2 minus 1, which is just 2x, plus. What is the derivative of kx? It's k, so it means this will be plus 3. So it means if we do not get 2x plus 3 by using the long method, it means something's wrong. So from the formula, we know that according to the f prime x, it says the limit when h approaches 0 of f of x plus h minus f of x all over h. So what we're going to do is we're going to say, okay, fine. Now, since we know that, okay, what we can do is we can just first expand, because this was just a formula. We can first expand our the f of x plus h, because already we need to get f of x plus h, because already we have f of x. So we're going to do this. We already have f of x. F of x is x squared plus 3x. Now we want f of x plus h. What does this mean? It means in the first equation, wherever we see x, we're going to replace x with x plus h. So it means this becomes x plus h squared plus, wherever we see x, we replace it with x plus h. So this will give us, we can expand this x plus h together with x plus h. Let's remove the brackets, 3x plus 3h. Then now we can expand this binomial by binomial, okay? So x by x, this becomes x squared plus x times h is xh, but it's two of them. So I'm going to say 2xh plus h squared plus 3x plus 3h. Already we know the answer that we're supposed to get by using the rules of differentiation. So let's now continue. We're going to say, okay, fine. We know the formula, it's f prime x equals to, now we have this. So I'm going to say the limit when h approaches 0. So without having to write the f of x plus h, because I already have indicated what is the f of x plus h, then now the answer would be, we have to substitute there. Okay, just a minute, guys. Okay, so now we are going to do this. We're going to say, okay, fine. Our f of x plus h, we already know it's x squared plus 2xh plus h squared, then plus 3x plus 3h minus, then we substitute by, we have to put brackets here. What is our f of x? Our f of x is x squared plus 3x. And always, guys, you need to put brackets here, then over h. Then this will give us the limit when h approaches 0 of, let's remove brackets. This will be x squared plus 2xh plus h squared plus 3x plus 3h. Let's multiply by negative to remove the brackets here. So this will be minus x squared minus 3x all over h. And obvious sum of the term will subtract here. So which term are going to subtract? X squared minus x squared is 0. 3x minus 3x is 0. So we're going to remain with the limit when h approaches 0 of, what are we going to remain with? 2xh plus h squared plus 3h all over h. Now we need to take a common factor of h. So we're going to say the limit when h approaches, what is the common factor of the numerator? It's h. So we're going to have 2x plus h plus 3 all over h. So the h and the h will divide. Then we're going to remain with the limit when h approaches 0 of 2x plus h plus 3. And by taking h, but for h approaching 0, it means the final answer would be f prime x would be, we do away with the limit, it would be 2x plus 3. So already you see that is the same as when we use the rules of differentiation. The approach is the same, guys. It's just that first principle is the longer method of finding a derivative. Remember, practice makes perfect. This is one of the easiest, guys. This is one of the easiest. Remember, you must know what is the reason of learning differential calculus. We're actually applying differential calculus to know more about gradient at a point. Gradient at a point, not at 2 points, but the gradient at a point. So it's very important to be able to know how to explain first principle and how to use first principle in solving problems. There are a lot of questions that we can solve here. However, I will create a video to address almost everything about the first principle. It's very important. So it means a question that we will speak about the first principle and the rules of differentiation. They actually comes in one question. After that, then they talk about what? A cubic function or a curve sketching. So it is very important to be able to know how to actually deal with differential calculus. And one other thing is they can say to, for example, they can say, they can give you a function. This is okay, our function is x squared plus 3x. And they say, determine the gradient. Determine the gradient at maybe at x when x equals to 3. You see, they want us to calculate the gradient when we know that x is 3. And what did I say? I say, remember now we're given 1 point. Unlike when we're given 2 points, but we're just given the x coordinate of just the x coordinate. So we want to know what is actually what will be the gradient when x is 3. Obviously, since we do not have 2 points, we have to apply differential calculus, because I said once you do this, once you do this, you are actually talking about a gradient function. This is a gradient function. So it means we have to differentiate our equation with respect to x. Obviously, we're not going to use first principle because it's the longest. We use the rules of differentiation. Number one, this is x to the power of n. We bring down the n and reduce the n by 1. This will give us 2 plus 2x. This is kx. What is the derivative of kx is k. So it means this will give us 3. So it means where there is x, we're going to substitute x by 3 to get the gradient. So it means the gradient will be where there is x, we substitute by 3. This will be 2 times 3 plus 3, which is 6 plus 3, it's 9, which means the gradient when x equals to 3, it's 9. So it's very important to know this. Sometimes they can also say determine the equation of a line. Obviously, to get the equation of a line means since we know the value of x, we can still know the value of y by substituting into the original equation. Then already we know the gradient. So it means calculus. Calculus can work in functions and graphs, can work in sequence and series, so you need to be able to know how to use it actually how to apply calculus when you're solving problems. So this is one of the easiest questions. Particularly I'm actually talking to those who can, like, if you want to enjoy differential calculus, number one, you must know how to differentiate. I'm not referring to when you know how to differentiate by using first principle. First principle is the longer method of finding a derivative. We still have the rules of differentiation. The answer is the same. The answer is the same. Right. Then now, again, number 2, 5.2, you need to familiarize yourself with a curve sketching or cubic functions. When you are dealing with cubic functions or a curve sketching, number one, you need to know the standard form of a cubic function. And what is the standard form of a cubic function? It's y equals to ax cubic plus bx squared plus cx plus d. Y equals to ax cubic plus bx squared plus cx plus d, which means when we are dealing with a cubic function, it has the highest power degree of 3. And this coefficient of x cubic, which is the a, is telling us about the shape of the cubic function. It's telling us about the shape of the cubic function. When the a is a number bigger than 0, the parabola, no, I'm sorry, the cubic graph first, it starts with the sad face, then comes with a smile face. So it starts with the sad face, followed by a smile face, where a point between the turning points, which we're going to talk about, the point of inflection. Now, and if the a is less than 0, the graph starts with the smile, then comes with the sad. You'll see when we're going to draw the graphs. So it's very important to be able to know how to deal with a cubic function, how to actually sketch or deal with a cubic function. Remember, I told you sometimes it's very important to know what you're doing. Now, the question is, what are the steps of sketching a cubic function? What are the steps of sketching a cubic function? One must be able to know the steps of sketching a cubic function. Number one, when you are sketching a cubic function, you need to be able to know the x-intercept. X-intercept, it means you have to let y to be 0. Secondly, you need to be able to know about the y-intercept. About the y-intercept, we let x to be 0. Then number 3, you must be able to know how to determine the turning points of a cubic function. Listen to me, guys. Remember, if you look at the graph here, where is the graph turning? The first one. The graph is turning here, and it's also turning here. You see that this one becomes a local minimum turning point, and this becomes a maximum turning point. So one is the maximum turning point, and one is the minimum turning point. And now look at this. Where the graphs are turning, they are not increasing and they are not decreasing. The graphs at the turning point are not increasing and they are not decreasing. So it means we know that where we have a function that is constant, the derivative of or the gradient at a point where the line is not increasing or decreasing, it's 0. So where the line is not increasing or decreasing, the gradient is 0, which means when we are calculating the turning point, first of all, we need to take our function or the function we differentiate it to equate to 0. Why are we equating this to 0? Is because we want the value of x where the gradient is 0. We want to determine the value of x where the gradient is 0. Because again, we said, remember, f prime x is the same as gradient function. So it means when we're determining the turning point, at the turning point, the graph is not increasing and it's not increasing, which means its gradient is what? It's 0. So it means all the time we have to make f prime x equal to 0. After equating to 0, we solve for x values. We need to solve for x values. So we solve for x values. Then after solving for x values, we do what? We substitute the x values into the original equation, to get y or to obtain y, into the original equation to obtain the y values. So you substitute the value of x into the original equation, you equate it to, you substitute them in the original equation to get the y values. And guys, you need to be able to understand. Remember, I said something about when we have a quadratic equation to say, do you know or do you understand how the axis of symmetry came from? Axis of symmetry, it came from the calculus, because we know that where the graph is turning, the derivative is always 0. And if we take this, we differentiate with respect to 0, this will become 2ax plus b, because the c is 0. And when we solve for x, we're going to have 2ax equals to minus b. We divide by 2a, then x becomes minus 2 over 2a. This is because of differential calculus. That's why it's very important for you to be able to know that when we talk about derivative, we're actually talking about a gradient at a point. we talk about a gradient at a point. We actually talk about the gradient at a point, ladies and gentlemen. So it means when you are dealing with a curve sketching, if you want to sketch a cubic function, you need to get the x-intercept, you need to get the y-intercept, you need to get the turning point. For example, even if the graph comes being sketched, so you must ask yourself, how did they sketch the graph? It means they've determined the x-intercept, they determine the y-intercept, they determine the turning point where we make the first derivative to be equal to 0. We solve for the value of x after a derivative. And after solving the values of x, we substitute those values of x into the original equations. So it's very important for you to be able to sketch the cubic function. Now, number 3, guys. Okay, before moving on to number 3, when we are sketching a cubic function, we also have these additionals or the other things that they can add in the equation or in the exam that involves cubic function. Number 1, it is the issue of understanding the issue of concavity. You must be able to interpret the values of x for which the graph becomes concave up and concave down. Let me explain this. Remember we said, let me explain this. We said when we are doing a derivative, once you do this, you are actually calculating what? A gradient at a point. So it means if this is the gradient at a point or a gradient function, it means we know if the gradient it's bigger than 0, it's positive, it means that line is actually increasing. So it means where the line is increasing, its gradient should be bigger than 0. So that's what I'm saying. Once you see f prime x, you know we're talking about gradient. Then it means if the gradient of a function is what? It's bigger, it's less than 0. It means that line is actually increasing. I'm saying decreasing, I apologize. The line is decreasing, it's a decreasing function. So the function is actually decreasing. The function is actually decreasing. But now, how about when the first derivative is actually equals to 0? Obviously, it means the line is not increasing or decreasing, is just stationary. So it's very important in the exam to be able to understand that, f prime x, that f prime x or dy over dx, this just means the gradient. So if the gradient is positive, we know the line will increase. And if the gradient is negative, we know the line will decrease. And if the gradient is not negative, it's just 0, the line will not increase and will not decrease, it will just be constant. So it's very important to be able to know that. Now, what does this mean? It means, look at this. If I take my function, let's say we take my function. If you look at this, and also we look at this, you see that this function, now these are parabola. I want to talk about in the context of parabola. Why am I doing this? We want to talk about something called second derivative test. Second derivative test. So it means when we are dealing with second derivative test, this has to do with when we want to check whether the turning point is the local maximum or is the local minimum. Let me talk about first if you look at this parabola has a smile face. And since this parabola has a smile face, then it means this is concave up. This is concave up, and this is concave down. And now look at this. Wherever we have a concave up, let's look at where the graph is turning. The graph, it is turning at the minimum turning point. But wherever we have concave down, the graph has a maximum turning point. I want you guys to listen to me very well. Which means that when the graph is concave up, we can now talk about what we call the second derivative test. I want us to talk about this. Second derivative test. If the second derivative test is a number less than 0, it's negative actually. If the second derivative test is actually negative, you must know that when the second derivative test is negative, it means you have a concave, you're dealing with concave down. And where there is a concave down, always you're going to have a maximum turning point. But when the second derivative is actually 0, it means you do not have concave up or concave down. This is called the point of inflection. Actually, this is the point of inflection. It is just the point where the graph changes its concavity, which means it changes from being concave up to concave down, or concave down to concave up. So this is called second derivative test. When the second derivative test is 0, then we know we have a point of inflation. But if the second derivative is bigger than 0, we have concave down. Concave up. Concave up, which has to do with what? Which has to do with the local minimum turning point. That's why usually I used to say, if you want to recall this, you can just take it and say, okay, this is a parabola. We know that when the value of A on a parabola is positive, the graph will smile. And when the A is negative, the graph will be sad. So you see that we can take this as our A to say when A is negative or less than 0, our graph has a sad face. And having a sad face means to have concave down. But if the second derivative is actually 0, it means you have the point of inflation. We do not, it means it's just a point where the graph changes from concave up to concave down, or concave down to concave up. It's very important. But when the second derivative is positive, it means is the case where we have a smile face. And smile face happen when we have concave up, or yes, and also have the local minimum. There's a minimum turning point when we are dealing with concave up. See, these are exam typical questions. You need to be able to know this. Don't forget, guys, I'll be creating a video where we'll be solving problems that are relating to differential calculus. Number one, we know when we are sketching a cubic function, you must get the x-intercept, you must get the y-intercept, you must also get the turning point. And at the turning point, where the graph turns, the gradient is 0. That's why we are making a derivative. We're differentiating our function. We're equating it to 0 because where the graph is turning, the gradient is 0. So it's very important to be able to know this. Let me remind you first, again, like in terms of knowing how to remember the second derivative. What you can do this. Okay, fine. You can say, okay, right. I know when I'm dealing with a parabola. Remember, if you take a cubic function, you differentiate it once. That cubic function becomes a parabola, because remember, you convert it from being cubic to parabola. So it means if we take a parabola, we differentiate it once, to give us a linear function or a straight line. So now I want to remind you something, or I want to show you a way of, like, the way where you can, like, the best way of remembering the issue of concave up and concave down. Right, let's go back to the issue of parabola. We said on a parabola, if the value of A is bigger than 0, if the value of A is positive on a parabola, will the graph have a smile face or a sad face? If the A is positive, will the graph have a smile or positive? I mean, if the A on a parabola is positive, obviously the graph will have a smile face. And if the graph starts to have a smile face, what does this mean? It means we have concave up. This is concave up. And where there is a concave up, the turning point is the minimum. So we're going to have a minimum TP. So which means that, listen to me. But when the A is less than 0, what does it mean? The graph have a sad face. A sad face. And where there is a sad face, it means we have concave down. And whether we have a concave down, actually it goes with the maximum turning point. So I want to show you this. You can do the lenses. Okay, fine. Since here we're talking about A, when A is bigger than 0, we have concave up. You can take it as the second derivative. You say, okay, this is the second derivative. The second derivative must be bigger than A. So it means that's why you're going to have concave up. But the second derivative, when it's less than 0, then this will be concave down. And where we have a concave down, we have a maximum turning point. So it's very important to understand that. And when the second derivative test is 0, it means this is the point of inflection. Point of inflection. It means the graph changes its concavity from concave up to concave down, or down to up, depending on the questions actually. So it's very important to be able to know this. And again, guys, you must be able to know the issue of transformation, the issue of reflection about the x-axis, reflection about the y-axis, shifting certain units upwards, downwards, it's also applicable when you're dealing with a differential calculus. Then again, we'll do an example based on curve sketching. For example, remember if they say to you, let's say they give you a graph or a cubic function that is already sketched, and they say to you, determine the equation of a cubic function. Now, this is what you need to consider. On a cubic function, like if you remember when you're dealing with quadratic, when we are given a quadratic function where you know the x-intercept and we know two of them and any other point, so the formula will be y equals to a into x minus x1 and x minus x2. So it means even when you're dealing with a cubic function, since if you're given 3x intercept, it means you're going to say y equals to a into x minus x1, x minus x2, and x minus x3. So these are the x-intercept, which means you must be careful. Sometimes you find that on the parabola, on the cubic function, there is a point that is the turning point, and at the same time, it is the x-intercept. It is the turning point, and at the same time, it means we need to repeat these values when we are sketching the graph. Where there's a turning point and at the same time is an x-intercept, we need to repeat it here. So you need to be able to know that, but we'll talk about that when you're going to answer questions. So it's very important to be able to know this. And guys, the issue of optimization and the rate of change, I will encourage you to watch my video, but actually I focused on optimization. So I will share a link below for these videos so that you can familiarize yourself with the optimization and rate of change. So here I was just summarizing to you that if you want to determine, like if you want to enjoy differential calculus, you need to make sure that you spend more time on first principles, rules of differentiation, curve sketching. What are the steps of sketching a cubic function? You get the x-intercept, the y-intercept, and the turning point. And always where the graph is turning, the gradient is 0. So you make a first derivative, you equate it to 0 so that you can solve for the x values. After getting the x values, substitute them into the original equation to get the y values. And these are just additional, concave up and concave down, point of inflation. These are just additional, which we'll talk about that later. Then another thing is the issue of probability. I think this one, yeah, we'll have to talk about that, probability. Okay, guys, let's continue with probability. As I said, we went through differential calculus, first principle, and the rules of differentiation. Curve sketching, what are the steps of sketching a cubic graphs? I think I'll also create a video for differential calculus. And I've already created the video for optimization and the rate of change. Kindly, there is a video link that I've shared below. Kindly just go through it, then you'll enjoy the session for optimization and rate of change. Right, what is it that you need to know when you are dealing with probabilities? Number one, you must be able to use what is called the addition rule. You must be able to use the addition rule. And obviously with the addition rule, this is the rule that, like, this is this rule they actually provide a formula for you in the formula sheet, which says that the probability of A or B, the probability of A or B is equals to probability of A plus probability of B minus probability of A and B. And this OR is the same as when we can use probability of this union, or equals to the probability of A plus the probability of B minus the probability of A and B, an intersection. This is one of the easiest. Actually, they provide you with this formula, so you must be able to use it. Then again, you must familiarize yourself with the complementary rule that says that the probability of A plus the probability of not A complementary should always be equals to 1. So the probability of A plus the probability of not A is equals to 1. For example, if we know that the probability of A is 0.7, so it means that the probability of not A will be 0.3, because this must add up to 1. So this is called the complementary rule. I've already created a video but it's for grade 10 probability, but where I went through addition rule, complementary rule, mutually exclusive events, and a bit of Venn diagram, because remember in grade 10, they're not focused, they're not doing independent events, and the contingency table are not there. Right now, again, you must familiarize yourself with events that are mutually exclusive. Obvious events that are mutually exclusive, the probability of A and not B should add up to 1. Actually, when events are complementary, then the events are mutually exclusive. But again, we can explain mutually exclusive in terms of a Venn diagram. To say events that are mutually exclusive are those events that are having no intersection. They have nothing in common. They cannot occur simultaneously. So it means if we say this is A, we have event A and event B. So these two events are mutually exclusive. Why? Because the probability of A and B is 0. The probability of A and B is 0. So which means they cannot occur at the same time. Probability of A and B is 0. They have nothing in common. They have no intersection. That's why we say they are mutually exclusive. But if they are like this, let's say we have two events where we have, okay, I apologize. Let's say they're like this. So we call this, this is for event A and event B. You see now they are having an intersection. So since they're having an intersection, it means there is probability of A and B. So probability of A and B, it's not equals to 0. Obvious, if it's not equals to 0, it means they are not mutually exclusive. They are not mutually exclusive. They are not mutually exclusive. Why? Because the probability of A and B, it's not 0. And if the probability of A and B is not 0, it means they are mutually exhaustive. They are mutually exhaustive, mutually exhaustive, mutually exhaustive. So this is the opposite of mutually exclusive. They are mutually exhaustive, which means they have something in common. They have an intersection. That's why in the exam, if they say, prove that events A and B are mutually exclusive, they will be mutually exclusive if the probability of A and B is 0. And you must know this. If the probability of A and B is 0, under the addition rule, when you are using addition rule, it means you will not consider this part because the probability of A and B is already 0. So you only consider probability of A and B because this one is 0. So for mutually exclusive events. So you need to be able to know this. This is one of the easiest topic in probability. Actually, just in maths paper 1, you can even get total from this one, only when you understand what you are doing. And again, you must able to know the conditions that makes events to be independent. You must be able to know the conditions for independent events. Listen to me. Events that are independent, it means the occurrence of one event does not affect the other. So they are independent. So what does this mean? It means when you want to check whether events are independent or not, you look at the probability of A and B. I'm not talking about or, I'm talking about A and B. Now, listen to me. If the probability of A and B, it is the same as probability of A multiplied by probability of B. If whatever is on the right is the same as whatever is on the right and on the left are the same, then it means the events are independent. So events are independent if the probability of A multiplied by the probability of B are equal. So they are independent. So which means the occurrence of event A does not affect the occurrence of event B. So they are independent. They are so you must be able to, like in the question, if they say two events are independent, you must know, okay, the independent means event A and B should be equal to the probability of event A times event B. So it's very important to be able to know that. For example, let me just do one example regarding this issue of independent addition rule. And yeah, so let me just do one example. Guys, this is one of the easiest. It's one of the easiest chapter in paper one. So only when you know what you are doing. So let me just do one example. I think I'll create a video for probability only, particularly for grade 12, because already I've done that one for grade 10, but however, you can still go through it. I'll share a link below so that you go through it and you try to understand some concept behind Venn diagrams, complementary rules. I even done examples there, right? For example, let's say as an example, we are told that you must read question. If they say event, let's say they say event A. Okay, let me just use different letters. Events S and T are independent. It's a condition. Event S and T are independent. We are told that they are independent. And now, probability of S and T, probability of S and T, it's 1/6. And probability of S alone is 1/4. It's 1/4. Then the first question says, calculate the probability of T. And secondly, it says, now calculate, hence, it says, hence, determine, hence, calculate the probability of S or T, the probability of S or T. Number one, we must first go through this. It says events S and T are independent. Independent. What do we mean? Okay, number one, we know that events that are independent. Okay, let me use events that are independent, ladies and gentlemen. The occurrence of one event does not affect the other, which means probability of S and T, we're using and, is the same as probability of S alone multiplied by the probability of T alone. We do this only when we are told that the events are independent. Right, now we already know the probability of S and T, it's 1/6. And we know the probability of S is 1/4. Then we're going to multiply this by the probability of T. And let's make probability of T the subject of the formula. So we're going to divide both sides by 1/4. So which means 1/6 divided by 1/6 divided by 1/4. This will give us 2/3. 2/3. In decimal, if you want to write it in decimal, it will be 0.67, but we can just leave it for now. So this is this is the answer. Why are we using this? Because they told us that the events are independent. We are told that the events are independent. Then secondly, it says, hence now calculate the probability of S or T. Once it says or, you must always think of addition rule. So let's go and write down the addition rule formula. It says for S or T, we're going to say probability of S or T as an addition rule. This is the probability of S, not S only, plus the probability of T minus the probability of S and T, S and T. Now, what we're going to do is we're going to say, okay, what is the probability of S? The probability of S is 1/4. And what is the probability of t? Probability of t, it's 2 over 3 minus the probability of S and T is 1 over 6. Then we'll get the answer. So we're going to say 1 over 4 plus 2 over 3 minus 1 over 6. And this will give us a probability of 3 over 4, which is roughly 0.75. Now, we can also do this. In the exam, they can say, using this information, construct a Venn diagram. Construct a Venn diagram. You can still construct a Venn diagram looking at the events. Let us just try to construct this Venn diagram using the information provided. Right. First of all, okay, let me try to raise it. Remember, this is just a tips for you to actually get an A in math paper 1. Already I've done the first part video. Kindly, if you have not watched it, there's a link provided above there on your on the screen. Then you can right click there and view watch the video before completing this one. Right. Okay, let me just construct. Let's say we have 2 events. Let me just call this event A, S, and event T. So let me just use different. So this is S and this is T. So we want to construct a Venn diagram. Right. As I said, because now we are dealing with probability, the probability of the sample space should always end up to 1. So it means this area, in terms of its probabilities, must end up to 1. Usually when we are constructing a Venn diagram, let's first look at where there is an intersection. Where there is an intersection, we need to first get this probability of S and T. Obvious, first of all, we'll have to do this. If we do not know the value, we'll just substitute that by X. All right, now we're going to say, what is the S and T? We are told that S and T is 1 over 6. 1 over 6 in decimal is 0.17. So we can just say, okay, now we know the probability of S and T is 0.17. Okay, let me just try to... Okay, 0.17. Okay, I believe you can see it means the probability of S and T is 0.17. But now, what is the probability of the whole of S? What is the probability of the whole of S? The whole of S. The probability of S, it's 1 over 4. So within 1 over 4, remember 1 over 4 is 0.25. So it means this area here, this area together with this must add up to 0.25. But already we have the probability of S and T. So within that 0.25, we can subtract 0.17. So it means the probability of S only will be 0.08. Let me use the probability of S only will be 0.08. S, it means it is S and not T. It is S and not T, which is S only. And what is the probability of T? Probability of T, we know it's 2 over 3. And 2 over 3, it's 0.67. 0.67 is 2 over 3. So which means this area here, the whole of this area must add up to 0.67. So within that 0.67, we'll subtract 0.17 for S and T. So 0.17 for S and T. So it will be, okay, 2 over 3 is 0.67. 0.67 minus 0.17, it means this will be 0.5. 0.5, it is the S, this is the T, probability of T only. But now, remember I said these probabilities must add up to 1. Remember, if you have this, if you have in a Venn diagram, let's say you have, okay, let me just talk about that S and T. Remember, if you take S and you take T, this is S, this is T. If you add this area, this one is the same as S or T. This is S or T. That's why if we add 0.08, 0.08 plus 0.17 plus 0.17 plus 0.5. This will actually give you 3 over 4, which is 0.75, because that is S or T. That is S or T, which means the probabilities are not adding up to 1. So it means we have a space. We need to get the probability where it's not S and it's not T. It is not S and it's not T. This other part, not S, S not and T not, which means how will you get that? It means this area must add up to 1. So it's going to be from 1 minus 0.08 minus 0.17 minus 0.5. Or we can just say 1 subtract the probability of S or T, which will give us 1 over 4, which is the same as 0.25. Because this one, remember, if we know the probability of A or B, this is the same as 1 minus the probability of not A and B. Why? Because remember I said, if we know A or B, the other part is not A and not B. So we can still say if within the one, the A or B or the S or T, S or T, if you say 1 minus probability of S or T, which is 3 over 4, it will give us 1 over 4. These are some things that you need to be able to know when you are dealing with probability. Issue of being able to construct a Venn diagram. It's very important, ladies and gentlemen. It is very, 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 very important, ladies and gentlemen. For example, in the exam, they can say, within the constructed Venn diagram, what is the probability of, I just want to give an example. What is the probability of not A or B? What is the probability of not A or not B? This is an example. So let's say they say to you, what is the probability of, just an example. No, why am I talking about A instead of S? Okay, that's fine. Let's just say, what is the probability of S or not T? Yes. What is the probability of S or not T? So we want the probability of S or not C or not T. Obvious, he's talking about or. So the best way to do this is to first write down the addition rule. So, okay, fine. I know probability of S or T. It's probability of S plus probability of T minus probability of S and T. Okay, let me just use an intersection. Probability of S and T. This is just my addition rule. But now look at this. What do we want here? We want the probability of S and not T. We are negating on T. So it means we need to negate also on T throughout. So what does this? It means now we want the probability of S or not T. So this will be the probability of, okay, apologies. The probability of S, or not T, the probability of S or not T, this would be, what is the probability of S? The S we know, we're given S, it's 1 over 4, plus, what is the probability of not T? Obviously, not T, it is the opposite of T. Remember, complementary rule. We know that probability of T is 2 over 3. Then it means to get the probability of not T, it will be 1 minus 2 over 3, which is just 1 over 3. Another way to do this, we can read it from the Venn diagram. Remember, this area is for T. So anything that is not of T means it is outside that part. So we're going to add 0.25 and 0.08. So 0.25 and 0.08, that is also will give us 0.33, which is 1 over 3. 0.33 is the same as 1 over 3 minus the probability. Okay, I forgot to put the not T. So we want S and not T. What is this? S and not T. Where there is S and not T is the same as probabilities of S only. The probability of S only. This part, this is the probability of S only, because it's S and not T. And what is the probability of S only? The probability of S only is 0.08. So it's 0.08. So it's S and not T. So it's 0.08. So it means this will be 1 over 4 is 0.25 plus 0.33, which is 1 over 3 minus 0.08. So this will give us a probability of 0.08. 0.5. This will give us the probability of 0.5. So it's very important to be able to know how to deal with probability, especially addition rule, complementary rule, mutually exclusive, and independent events. These are very important. You must be able to know that events that are independent, the probability of like the A and the B should be equal to the probability of A alone multiplied by the probability of B. And the other thing, it is the issue of constructing a tree diagram. The issue of constructing a tree diagram, whether when we are dealing with replacements or no replacements. When we are dealing with replacements or no replacement. So this is very important in terms of probability. Tree diagrams. Let me talk about tree diagram. Right, tree diagram is just a way to actually simulate an outcome based on events that are actually independent. Based on events that are independent. Usually, when we are dealing with tree diagrams, we are talking about events that are actually independent. Let me just give you an example. Let's say we have like we're given a bucket of sweets. Inside this bucket of sweets, there are, let's say we're given 2 types of sweets. We're just given 5 red sweets, and let me just say 5 red sweets and 4 blue. So it's only red sweet and blue sweets only. So it means this is actually our sample space. So the sample space has how many sweets? 5 red sweets are it's 5 of them, R and R, right? And blue sweet 4, blue and blue and blue. So this is our sample space. Now, what will be the sample size? The sample size, it will be 9 sweet, only 9 sweet. So it means the probability of just getting a red sweet, it will be the number of those red sweets divided by the sample size, which means here we're going to have 5/9. So it means the probability of not getting a red sweet, it means you're going to get blue, is the complement. Obviously, the blue will be 4/9. So if you know this, because these are from the same sample space, then to get the other ones, you just say 1/, but still it's 4/9. Right, now what would they say? This, okay, right. They can say to you that you have to randomly select a sweet. You have to randomly select a sweet without looking, randomly so. But at the end, you must have 2 sweets with you. So it means you don't just take 2 sweets at a time. You take the first sweet, then again after selecting the first sweet, then you come and select the second one, randomly so. Let's say, sometimes this can say with replacement or without replacement. So if they say with replacement, it means you can take the first sweet, you record the color, and you return it, you return the sweet in the bag. So now there are 2 conditions. Sometimes you can take it and you don't record the color, it means we're talking about without replacement. So you must consider these things: with replacement or without replacement. Without replacement. And guys, when you are dealing with a tree diagram, we always assume independent event, because the occurrence, for example, for me to select the first sweet, it does not depend on, like selecting the second one does not depend on what I've already got initially. So it means in terms of a tree diagram, we'll say, okay, fine. For the first time, I can randomly select the sweet, but I can get a red sweet or I can get a blue sweet. I only have 2 options or 2 choices. It's either I get red or blue for the first time is the choice that I can get. Remember, you randomly select a seed in the bag. So it means now these tree diagram, these trees must have their associated probability. Then I'll say to you, what is the probability of just selecting a red seed for the first time? Already it will be 5 out of 9. And listen to me, if we know this first branch, then to get the other one, it's easy because these probabilities must add up to 1. So it means here I already know this will be 4 over 9 because these trees must always add up to 1. But if we say we are dealing with replacement, it means if I got the seed, a red seed for the first time, that means I have to return it back into, I have to return the color, the seed in the back, which means the sample size will not change. Even the probability will not change. All right, it means now, remember this was for the first time. So it means if I do this again, since I got a red seed for the first time, there's a possibility that I can get a red seed again, or I can get a blue seed again. So it's either a red or blue. So it's either red or blue. Or, okay, now, again, if I got blue for the first time, there's a possibility that I can still get red. I can still get red for the second time, or I get blue as an outcome. So it means now, blue as an outcome. Then now it means that since we are dealing with replacement, what is the probability of getting a red seed from the still? Because I got the red, then I return it back like it was returned. So it means I will still have the same outcome. It's going to be 5 out of 9, 5 out of 9. And if this is 5 over 9, this is 4 over 9. And what is the probability of getting red this side? This is still 5 over 9. And this side is 4 over 9. So in terms of the outcomes, I want to explain something here. Here you need to write down the outcomes. Here it is the outcomes. You must write down the outcomes, okay? So the outcomes would be red and red, red and red, red and blue, blue and red, and blue and blue. Right, there's something good about a tree diagram. When we are dealing with tree diagrams, we always assume independent events. We assume that the events are independent. What does this mean? The occurrence of a red sheet in the second trial does not depend on the first one. So which means that we must know that, for example, if I want to know what is the probability of red and red, the probability of red and red, this is independent. So I have to take the probability of the red multiply by the probability of the red. So which means here I'm assuming independent. So to get the outcome for this one, I have to multiply this with that. So this will be 5 over 9 multiplied by 5 over 9. But if I want to get the probability of red and blue, we assume independent, it's going to be the probability of red multiplied by the probability of B. What is the probability of red? 5 over 9. Probability of B, 4 over 9. So these are the answers. Then what is the probability of blue and red? Blue and red, it will be, for blue will be 4 over 9, is this one. With red, it will be 5 over 9. Then we get the answer. Then how about blue and blue? Blue and blue, it will be 4 over 9 multiplied by 4 over 9. We assume independent. So this will be 25 over 81. And this will be 20 over 81. This will still be 20 over 81. This will be 16 over 81. So remember, probabilities must add up to 125 plus 20 plus another 20 plus 16. This is 81. So you see that sometimes the exam, they can ask you this, to say, what is the, for example, what is the probability of just getting a red or a blue sheet? So it's very important to be able to know that. Okay, just a Okay, guys, let's continue. I apologize. So as I was saying that when you are dealing with the tree diagram, always assume independent. But now, how about if we are saying we are not dealing with the replacement, without replacement actually. So how do you answer this? For example, if we say in terms of without replacement, the only difference, these probabilities will not change. The only difference will be this side. How? It means I'm going to say, okay, if we are saying we are dealing with without replacement, means if we got a red sheet for the first time, it means that red sheet, since we got it, it means we're not going to replace it. So it shows that the number of reds will no longer be 5, there will be 4. So it means the probability of getting a red now, it will be 4 out of 8 because it reduced the total number of the sample space. So it will no longer be 8. Now I'm saying 9, it will be 4 sheet out of 8. And if there's 4 sheet out of 8, means this will not change this one. It will only change the sample size because this must add up to 1. You see that this has changed because the red sheet, because we got it for the first time, it means they will no longer be having 5 sheet red. There will not be 4 out of 8. So it means the blue will still be 4 out of 8. But if we got blue for the first time, remember, since getting blue for the first time, it means red will not change. What will change is the blue. It means we'll no longer be having 4 blue. Now there will be 3. So it means the probability for red will just be 5, but out of 8. Then for blue, total number will just be 3 instead of 4 because we got red for the first time. Then now it means the outcome now would be 3 out of 8. Then we still assume independent events. We still assume independent event, which means the probability of A and B is equals to the probability of A times the probability of B. I believe you guys are following. Then let's now continue. Right, I'll do a video for probability. Then the other thing, it is the issue of contingency table. This is one of the easiest of them all. Contingency table, one of the easiest of them all. Right, in terms of contingency table, it's just a table that compares. Actually, they call it a two-way table. Yeah, it's called a two-way table. It's just the table that actually compare to like multiple events. For example, let's say we have this. Let's say we are talking about like we're having, let's say in total we have 40 learners who are doing mathematics. And within these 40 learners, let's say among the 40, we have males and females in terms of gender. And within the males and the female, we want to compare how many of those males are right-handed. No, how many of these learners are right-handed and how many are left-handed. This is an example of a contingency table. Right, within this contingency table, okay, I'll just write the total here. We know that from the 40, it's only 30 learners who are males. Okay, let me just, okay, let's say it's only 30 who are males. Okay, let me just try to change this. Let's say, okay, let's say it's only 18 who are males, 22 are females. Oh, okay. I apologize, guys. I said L instead of F. Okay. Then now we want to compare the males and the female. Okay. We have 18 males and 22 female. So which means that in total, we'll have 40 learners. So it means males I mean, 18 are girls, 22 are, I'm saying 18 are girls, I'm saying 22 are girls and 18 are boys. So now, if we add this we know it will give us a total of 40. Now, among those learners, it's only, let's say, it's only 10 who are males and right-handed, but 8 are female. Then now within the 22, no, I apologize, guys. It's only 10 who are males and right-handed, and 8 are left-handed. Then now, within the 22 females, only is just an example. Only 15 females who are left-handed and 7 are right-handed. So it means this will add up to 17 in total, and this will add up to 23. So obviously when we add 23 and 17, still it will give us 40. Now, we can still use this contingent table when we are calculating probability. And guys, ladies and gentlemen, you must know something. When you are calculating probability, you need to always use the total number of these outcomes, because this is our sample size. Right, now let's look at this. For example, if I say to you, what is the probability of getting a male? Just a male, irrespective of whether it's left-handed or right-handed. So it means we have to count the number of those males and we divide by the sample size. Then what is the probability of male? Male is just 18 over 40. Now, if I say, what is the probability of getting female? Already that would be 22 over 40. But if I say, what is the probability of getting people who are learners who are right-handed, irrespective of whether they're males or female, learners who are right-handed, so it's only 17. So we're going to say 17 out of 40, they are right-handed. What is the probability of getting learners who are left-handed? It's just going to be 23 out of 40. Okay? But if I say, what is the probability of getting learners who are males and left-handed? Males and left-handed. So it means we look at the intersection. Males and left-handed is only 8. So you're going to say 8 out of 40. So they are males and left-handed. So what is the probability of getting females who are right-handed? So right-handed, female and right-handed. So we look at the intersection, female and right-handed, it's 7. So you only will have 7 out of 40. You see, we look at the total number. Are we together? So if I say, for example, what is the probability of getting males or a left-handed person? A male or left-handed person. You see, now this is or, which means you have to use addition rule. So we're going to say we want the probability of a male or left-handed, which is the same as probability of male plus probability of left-handed minus probability of male and left-handed. Now let's do the calculation. What is the probability of getting a male person? Male is just 18 out of 40 plus the left-handed. Left-handed means we're going to add this. So this would be 23 out of 40 minus male and left-handed. Male and, so it's going to be 8 out of 40, which means this would be, so 18 plus 23 minus 8, then this will give us 33 out of 40, which is just 33 out of 40. It's, I apologize, it's 0.83. So this is an example of a contingency table. So it's one of the easiest. So I'll create a video particularly on the contingency table. So you must be able to know this, right? Okay. Right now, yeah, like in the exam, they can ask you this kind of question. Sometimes they bring this contingency table with unknown values, so you need to be able to work out and get the answers there, right? Now we can move at the last part. Which is the fundamental counting principle. Fundamental counting principle. This is also one of the easiest topic actually in maths paper 1. Only when you know what you are doing, right? Remember, let me just give one example. Let's say you have, listen to me, let's say you have the word mathematics, or let's just consider the word math, right? Fundamental counting principle is just telling us, or assisting us to know the combinations or the number of outcomes that we can get if we are arranging or we are choosing with repetition or no repetition. For example, let's consider the word math. And we want to know how many possible combinations, or how many ways can the word math be arranged if repetition is allowed. It means we want to create words from using these letters. We are creating words using these letters. What does it mean? It means the words that we're going to create here always will have 4 letters. They will have 4 letters. So it means we want to create words that has 4 letters. Now let's ask ourselves, if we're creating these words, but we are allowing repetition, what does it mean? It means when we're allowing repetition, it means in a word, since we have letter M, we can repeat this letter M like many times. So it means to choose the first letter, we only have 4 options. We can use M, we can choose A, we can choose T, we can choose H. And also to choose the second letter, since we are allowing repetition, we can still choose that M. So we still have 4 ways. So this will be 4 multiplied by 4, which is just 4 to the power of 4. So you see, this is when we are allowing what? When we are allowing letters to repeat. So it means we'll have 256 ways. But if we are not allowing letters to repeat on a word, it means we're still gonna create 4-letter word. But to choose the first letter, we have 4 options. We can choose M, we can choose A, we can choose T, we can choose H. But to choose the second one, we have 3 options, because if we chose the M, it means we'll no longer use it anymore. So we'll have 3 options. And if we choose A and M, so we have 2 options. Then the last one will have 1 option, which is 4 times 3 times 2 times 2 times 1. Then now imagine, okay, 4 times 3 times 2 times 1, then this becomes 24 ways. So imagine when we have a lot of letters and we want to do this, then it means we must keep on reducing the n by 1. So there is a way of doing this, and this is one of the fundamental counting principle, which says when you have n, you reduce the n by 1, you reduce the n by 1 throughout, so it means up until getting 1. This is called something called factorial. So which means we can still use this without having, from our calculators, if you just say 4 factorial, it will actually give us 24. So this is one of the ways, like things that you need to know when you are dealing with a fundamental counting principle. Ladies and gentlemen, without wasting time, okay, fine. Let me attend to something, then I'll come back within some minutes, then to continue. So with the fundamental counting principle, I believe you guys are following. Okay. Okay. Just a minute, guys. Just a minute. Okay, guys, let's continue. As I was talking about the fundamental counting principle, that you have seen that when we said consider the like in the case of math, when there is repetition and when there is no repetition. When repetition is allowed, on the case of maths, where we are making arrangement, we have to arrange using, we have to create weights using the 4-letter maths weight. So you've seen that we said this is 4 to the power of 4, which is 256 ways. It's 256 because here we are allowing repetition. But if we are not allowing repetition, repetition not allowed. If we are not allowing repetition, it means we said it's 4 by 3 by 2 by 1, which is the same as 4 factorial. Now, which means that with 4 factorial, this gives us 24 ways. It's when we're not allowing repetition. But now, you see that in terms of not allowing repetition here, we used factorial. And when we are allowing repetition, we used what you call exponential form. So now it means that you need to be able to look at this. For example, if when you are dealing with an arrangement, it means you are using all the numbers or all the way. Actually, you want to use the total number of those combination items. You are not choosing. So if we say you are dealing with arrangements where repetition is allowed, when repetition is allowed, it means you're going to use exponential notation, n to the power of n. So if you are allowing repetition and you are dealing with arrangement, it means you have to use an exponential form or exponential notation. Why? Because I just gave an example to say, if we are having a 4-letter word maths and we are allowing repetition, it means you're going to have 4 to the power of 4, which is n to the power of n. But if we are not allowing repetition and we are making arrangement, it means this requires us to use the factorial, which is n by n minus 1 until 1. So this is factorial. So in the exam, you need to be able to check, are you arranging or you are choosing? But 7.2, in the case where we are choosing, let's say you are choosing R items from n. So you only have n items, but within that m, you do not want to use all of them. You want to choose R. You see, you only want R of them, which means usually R should be less than or equals to n. So you only want to choose R. You don't want to use all the letters. Not necessarily the letters, but the total number of items that you are having. So within the items, you only want R of those items. You don't want to use all of them. Same applies. If you want only R from n and you are allowing repetition, it's still a factorial. I'm saying still an exponential, but this time around is not going to be n to the power of n. This will be n to the power of R. For example, let's say we have we have 8 items, but within these 8 items, we only want 3 of them. So it means the R is 3. And we see we are choosing 3. We have 3 options of choosing from 8 actually. So now, which means Since we want 3 of them, so we're going to say, if we are saying we are allowing repetition, it means the first item that we're choosing, we have 8 options. Even the second option, we still, the second choice, we still have 8 options because the repetition is allowed. And same applies to this. So you see that you're going to have 8 times 8 times 8, which is just 8 to the power of 3. So you see that this is exponential, but we're not using all of them, but we want to only choose 3 of them. Same applies with repetition that is not allowed when we are choosing. When we are choosing, it's no longer a factorial, but it's what you call permutation. Which is n permutate r. From your calculator, you can have this from your calculator. And this n permutate r is the same as when you can just say n factorial. Divide by, you subtract, like from the total number, you only subtract r. It's on the same thing. But there's no need for you to go through this. Another way would be, for example, if we are saying, okay, fine, we only having what? We're having 8 items, we only need 3. So obviously means we want 3, we are going to have something like this. But if you are not allowing repetition, it means to choose the first item, we'll have 8 options. And to choose the second one, it will have 7 options because already the first one will no longer consider it anymore. And the last one will have 6 options, which is the same as 8 times 7 times 6. And 8 times 7 times 6 will just give us 336 ways. Which is the same as when we can use permutation from our calculator. What is our A? And it's 8, we only need 3. So if you, from our calculator, if we say 8 permutate 3, this will give us 336 ways. Or another way we can use this, n factorial divided by n minus r factorial. And what is the n? N, it's 8 factorial divided by, what is n minus r? 8 minus 3, it's 5 factorial. So if we take 8 factorial, we divide by 5 factorial, still the answer will be 336 ways. So I will create a video to talk more about this. Actually, look, if you're using all of them, allowing repetition, we use exponential. Not allowing repetition, we use factorial. But if you are only choosing r items from n, if we are allowing repetition, it means we're still going to use exponential, but the exponential will be raised to the power of r because we only need 3. But if you are allowing repetition, you are not allowing repetition, it means it's still factorial, but we need to subtract like only consider the ones that we already have. So it's going to be the n factorial divided by n minus r. Then now, how about when we are dealing with words that are having repeating letters? Words that are having repeating letters, this is what you should do. If they do not, or if they tell you that the repeating letters must be treated identical. Identical, it means even if you see that they are repeating letters in the word, we treat them as one thing. We treat them as identical. Or we treat them as different. As different letters. So if we treat them as different letters, it means we do not have repeating letters. We take them as if they're not repeating. So obviously this will require n factorial. We only consider n factorial if we are treating letters as different. But if we are treating letters as identical, it means we take the n factorial, we divide by the number of the factorial of those letters that are actually repeating. And so on. But usually in the exam, if they just give you a word, then they say, determine the number of combinations that we can get from the word. So if they did not say anything about treated identical, or you treat them as identical, repeating letters as identical. For example, let's consider the word mathematician. So this is one of the easiest chapter, only when you know what you're doing. So when you are dealing with ways that are actually repeating, ways with letters that are actually repeating, then you need to consider this. Okay, for example, let's look at the word mathematician. From the word mathematician, you can easily see that, okay, right, even if we are not told, from the word mathematician. Okay, let me write it down. Mathematician. First of all, you see that this ways on its own, it has repeating letters. M, the A's, the T's, the I's. Okay, M's how many? One, two, only two. The A's, 1, 2, 3. T, 1, 2. The I's, it's 1, 2. It's only 2. I don't know if I missed. But how many letters are here all in all? 2, 4, 6, 8, 10, 12, 13. Then if they say to you, what are the possible arrangement can we get from the word mathematician if repeating letters are treated identical? Identical, it means you're going to say, okay, those, we have the M's, we have the A's, we have the T's, and we have the I's. So we're going to take the 13 factorial, we divide by the factorial of those that are repeating. So we're going to look at the combination of M, the combination of A's, the combination of T's, and the combination of I's. So it means this will be 13 factorial. Actually, I was supposed to put n here. 13 factorial divided by 2 factorial times 3 factorial times 2 factorial times 2 factorial. Usually in the exam, if they say how many possible combinations, they do not mention the issue of you always do this. But if you are treating letters as different means we assume we do not have repeating, because it means if you say this one and this one are different, so it means we no longer have repeating letters. It means you're just going to use n factorial only, which will be 13 factorial. So I will create a video on the fundamental counting. So I just wanted to remind you that all the time when you are dealing with counting principle, you need to check: are you dealing with arrangement, or are you choosing, or are you dealing with repeating letters? Then again, you must be able to know about the condition of events that are independent. Obvious events that are independent. Let's say you have n options of choosing, like, yeah, let's say we have n1 and n2 and n3 and so forth. If they're independent, we just multiply. For example, let's say we have only 3 choices of let's say we are at the party or at the wedding. Then we are told that we can either eat either pap or rice, or what is the other one? Yeah, let's just say pap, rice, and let's just say cake, just an example. Then, like, okay, we have to choose within this, but in terms of the drinks, we have 5 choices of choosing the drink. And okay, by the way, we need to take this with relish. Okay, let's say we have to choose between Vors. The other one is chicken, beef, then stewed beef. Yeah, this is just an example. And okay, let's say we have how many options? 1, 2, 3, 4. So we only have 4 options. We only have, so you see that you can choose pap, with vors, chicken. So it means these are independent because we're having different independent. So it means choosing pub does not depend on the relish, whether you can take vors, chicken, and you understand. So which means you're gonna have 3 options multiplied by 5 options and multiplied by 4 options. You see, this is an example of independent event. And sometimes they can bring this in terms of factorial. So we can have n factorial multiplied by n2 factorial. And yeah, because we're dealing with independent event. So if you want to enjoy fundamental counting principle, you need to consider. For example, let me give one example before I call it off, because this is just the tips on how to actually get an A+ in maths. But I'll create a video for the fundamental counting principles. This is one of the easiest actually. So if you're having n items and you want to make arrangement of all the items, if you're allowing repetition, it means you have to use exponential notation. If you're not allowing repetition, it means you have to deal with factorial. But if you're just choosing, we are choosing r items from n, and you're allowing repetition, it's still an exponential, but it will be n to the power of r. But if you're not allowing repetition, it means you're not going to use factorial, it will be factorial. It means it will be a permutation. You consider the permutation. For example, let's say we have numbers from 0 to 9. Obvious, numbers that are from 0 to 9, how many are they? 10. If we say, how many ways? How many ways can a 4-digit code can be formed How many ways can a 4-digit code can be formed from the numbers 0, number 1, 0 to 9, if repetition allowed? Now, first of all, you need to look at this. You only have 10 numbers, but you only need 4. What is this? It's choosing. But since you are allowing repetition, what does it mean? It means we only need 4-digit code. We are creating 4-digit code using 10. And since we are allowing repetition, it means to choose the first number, we have 10 options. The second one, we have still 10, still 10, still 10. Why? Because we are allowing repetition. You see, that is the same as 10 times 10 times 10 times 10, which is the same as 10 to the power of 4. So we are using n to the power of r actually. But if we are just choosing, but repetition not allowed, repetition is not allowed. You see, it means you have to use permutation because we only need 4-digit code. And to choose the first number from the 10 numbers, we only have 10 options. The second one, it's only 9, 8, 7. Why 9? Because if you choose the first one, we're no longer going to repeat it. Second one, just like that. So this is 10 times 9 times 8 times 7, which is the same as n permutate r, permutation. 10 permutate only 4. So 10 permutate 4, this will give us 50, 40. But sometimes they can say repetition is not allowed, but the numbers must not start with 0. The numbers should not start with 0. Repetition is not allowed, but numbers should not start with 0. Numbers should not start with 0. What does this mean? It means, okay, we are creating 4-digit code. But the first number that we're going to select, it should not start with 0. It should not start with 0. What does this mean? It means already, if we do not want the code to start with 0, it means the first number 0 should be excluded. So only have 9 choices. But be careful. Choosing the second number, we can still use 0 because they said the number should not start with 0. The condition is on the first part. So we only have 9 options to choose the first number. But the second one, they said the numbers should not start with 0. What does it mean? It means you can now use 0 now. So it means you have 10 options. So we can use 0 here because they're just restricting the first one. So we can use 0 here. So it means we have 10 options. But since repetition is not allowed, since we choose the first number, it means we have 9 now, and this becomes 8. So it means we're going to have 9 times 10 times 9 times 8, which is just the same as 9 multiplied by 10 permutate 3. 10 permutate 3 multiplied by 9. So it's just 9 multiplied by 10 multiplied by 9 multiplied by 8. So it's one the same thing. Then the answer becomes 6480. Okay, guys, I will create a video about this. So it's very important to know. The n arrangement allowing repetition is n to the power of n. Not allowing repetition, it's n factorial. But when we are choosing, it's n to the power of r. When we're allowing repetition, not allowing repetition, it's n permutate r. Dealing with repeating letters, if you treat them as identical, it means you have to count the number. You divide by the factorial of those that are actually repeating. And if you not say anything, you just do this. But if you are treating them as different, you just use n factorial. Independent events is the way you are multiplying events that are actually independent. So you're just doing them like that. So, guys, this is one of the easiest. Remember, I said probability and fundamental counting principle, they come in one question, usually in the exam. So you make sure that you practice as many questions as possible. Remember, practice makes perfect. So it's very, 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 very important to understand what you are dealing with. Yeah, and guys, don't forget to like, subscribe, and share. And if you have not watched the first video, there's a link that I've shared below. Kindly follow the link, and I believe you will enjoy. Thank you very much for listening. Take care, guys.